All right. What letter would you put over this? The letter that we have already used for that. R. That is an R. Correct?
Yep.
Now, if I draw another line here, what have I just drawn? Another radius. Why am I able to name it R? Because all radii are what? The same in the circle. Agreed? Okay. Now, this guy here is what we call a tangent. Now, you've also heard that term in English. He's gone off on a tangent. Well, that means you're trucking around the circle, minding your own business, and all of a sudden, shoom, you shoot off this way. That's where it comes from. Or the other way we use it in English is you make a tangential reference to something, which means you refer to something, but you barely touch it. Okay? Everybody cool?
Yeah.
All right. So the tangent radius property states that if a tangent intersects a radius, what do we get? The resulting angle is what? Excellent. The resulting angle is 90 degrees. And what math does that allow us to do if we ever need to find this distance or this distance? Right, that allows for our good friend, the most important man in the history of mathematics, allows for Pythagoras. I actually have changed my mind about that. He is no longer the man I would consider the most important man in the history of mathematics. Until last summer, he was my number one go-to guy. But last summer I watched a documentary which introduced me to a bunch of other mathematicians, and he is still in my top 5, but I don't think he is the top anymore. Never mind. If you're interested, you should go and watch the show The History of Maths on Netflix. You won't, so it's okay. But if you do, The History of Maths with an S, because it's a British show, and they don't call math math, they call it maths with an S. Yes. All right. Buddha? Okay. Now, all of this information over here is what we call, what's the word I gave you for it on Friday when you get information that you get to put on the diagram? Starts with a G, ends with an N. What?
N?
Starts with a G.
Oh.
Ends with an N. Has IV in the middle of it.
Give.
What do you think?
Given.
Given. All of this is given, which means I get to put it in the diagram. So, BP is a tangent, okay? O is the center. So, when I read this, that tells me that OP is a radius. Why? How do I know that OP is a radius?
Because it goes from the middle of the it goes from the origin to the
From center to edge. And now, once I know that that's a radius, what do I now know? Since BP is a tangent, what do I know about that angle?
that it's 90 degrees.
OPB equals 90 degrees. Because of what we just proved, yes?
Yep.
Now, once I know that's 90, then how do I know what X is?
S equals
What does x equal? Because you just did 2 worksheets on this for me. I'm going to highlight in red the important shape that you have just made.
Ready.
And what do you know about triangles and angles? What? 45? 50?
But why are we going to no?
180.
It has to be 180.
Right?
So that has to be
That's 50. What do we know this is?
90.
90. So what's left?
70? Do I remember?
Oh, good God. 40. And why? Because 180 minus 90 minus 50 equals 40. Everybody Gouda? Good. Now fill in number 1. What's the name of the 90-degree angle, and what information does that tell us? Remember, the 90-degree angle has 3 names that I will accept there. So I'm going to rewrite it over here. Angle blank, blank, and blank all equal 90 degrees. And I'm going to write all 3 names there when somebody gives one of them to me.
Oh, you just want one C.
C. That's one name. What's another name for it? OCD. And the third name for it? DCO. Excellent. Now, what is angle X? Once I know that that's 90, I can draw it in. And what do I now know X is? Minus 90 minus 65, so X must be 25 degrees. Did we need a protractor?
No.
No. Everybody good? Excellent. Now, MB is a tangent. Oh, okay. So I know MB is a tangent. As soon as I see the word tangent, that tells me something. This is labeled as an R. Ooh, I have a tangent and a radius. What does that automatically tell me?
90 degrees.
That I have a 90 degree where they touch. And once I have a 90 degree, what very special shape have I made?
A triangle.
What kind of triangle?
This one.
What very special kind of triangle have I made? A 90 degree triangle.
I did it.
Which means what will work? Pythagoras comes to the party. Now, I need to find the radius. So I label all the sides. Okay, the hypotenuse is 10. This side is 8. So I need this side, yes? So what should I give it? A variable. What variable do I give it?
R.
I can give it R if I wish. I can give it A. I can give it B. What's the one variable I shouldn't give it, especially in your guys' world, because you guys are bad when this happens?
C.
I should not make it C, because that will screw you up, because you have been taught Pythagoras, A squared, B squared, C squared, which is a silly way to teach it, but I cannot go back in time. One of the number one things I would do if I had a DeLorean that could take me back in time would be go back and teach you guys Pythagoras, never using A squared, B squared, C squared. Never once. Ever. But I can't. Everyone says you would really use a time machine to go back and do that. You wouldn't do something more hardcore, like, I don't know, go back and kill Hitler or something. That would be dangerous. Teaching everybody Pythagoras properly, I don't think would change the world in any way but for the better. So, it is dangerous, though. You should never go back in time, of course. You can't. Here's a good reason why. I'm reading a book right now where a guy in the book invents a 2-second time machine, but it only goes into the future. You can skip the next 2 seconds of your life. He uses it when he's about to get yelled at, or if someone's about to throw water on him, or if he were about to be shot. Now, the argument is,
The butterfly theory.
it can't go. What would happen if it would go backwards? You would keep hitting it. You would get stuck in a loop. Right, I know. It's a crazy book. I'm having a lot of fun with it. Anyway, so let's do this math. Again, all the birds in the sky. I highly recommend it. Again, this can't be C. But, doing Pythagoras properly, leg, hypotenuse. Is that a leg or hypotenuse? It's a leg. So it must be r squared plus 8 squared equals 10 squared, yes? And then we do our algebra. Many of you are still screwing this up, even though we did a unit on exponents. What is 8 squared? 64. What is 10 squared? 100. Now solve it. Minus 64 minus 64. R squared equals 36. What is your last step in a Pythagoras question? Square root. R equals 6. Do you all understand that? And again, that can be done without actually knowing all the measurements in a situation. This is what we call indirect measurement. A great many of you have seen those dudes, often dudes, sometimes women. Great many of you have seen those people out on the street looking through a telescope at some other dude on the other side of the street. And you say, what are those dudes doing? This. They are measuring stuff without measuring stuff. Understand? Because it's a little hard to stop traffic while you and I, Karina, stretch a tape measure across the road. Wait! Time out! Just measuring here.
You can't do that.
This is the beginning of what they are doing. They are doing grade 9 and 10 math, but they are being paid tens of thousands of dollars a year to do grade 9 and 10 math. That's all the skill you need to do it, yes. So when you, as usual, one of you will eventually say, it doesn't matter what a tangent and a radius do. It doesn't. But the ability to use that knowledge might very well help you in the future. Of course, I cannot see the future, even if I had a 2-second time machine. Oh my good gravy, there's a lot of stuff going on in that question. The question gives me a bunch of information, doesn't it?
Yeah.
What does it give me?
The ST is the tangent.
ST is a tangent. Oop, tangent tells me something. It's a tangent at S. So right there, that point is a tangent point. If O is the center, a tangent point is automatically a point on the edge of a circle, then I automatically have a radius. Once I have a radius and a tangent, what angle do I have? 90 degrees. Which means I have what very special triangle?
Pythagoras.
A Pythagorean triangle or a right angle triangle. OST is 90 degrees. So now I do my math. Now, please notice I have changed the way we are writing it down, because there is no way to guarantee questions will be written for you the same forever, which is why a squared, b squared, c squared messes you guys up. This side is our math. This side is our reason. You cannot make a claim in math class without having a reason for it. So, OT is the hypotenuse, yes?
Yeah.
So OT squared equals what? No.
12 squared plus R.
Equals OS squared plus TS squared. Now we put in our numbers. What is OT?
OT is 16.
16. R we don't know. What is ST? 12 squared. Now we square those numbers. 256, 144. What do we do with this positive 144 over here? It becomes minus. 256 minus 144 is what? 12. What's the last step always? Square root 12, which we know to be a little less than 4, right? Because, huh?
112.
Yeah, 112. Sorry. 112. Which we know to be a little less than 11, right? Because 11 squared is 121, 10 squared is 100. We're about halfway between, so it's going to be around 10.5, but I don't have my calculator out. So what is it? 10.58, so 10.6. Does everyone get it? Now, guys, listen to me. You've only actually learned about 3 things, yeah? Right? But think how much you can already do with those 3 things. Angles on a line add up to 180. That told you all that stuff about this, yes? Angle A equals B, C equals D, and all you knew was that one fact, right? In this case, all you learned was one thing. If you make a tangent, it hits a radius, it makes 90 degrees. Now, that opens up this whole bit of Pythagoras. Can you forget this property, tangent radius, tomorrow?
If we're possible.
Should you forget it tomorrow? No, because we're probably going to use it again. Just like we use this simple fact so many times since. Understand? Okay. So, you guys have a bit of practicing to do here. I would like to go through each question. So, everybody do number 1, and in a couple of seconds, I'm going to fill in some right answers. If you finish 1, go on to 2, obviously. But when I stop you for the right answers, please stop working where you are and go back and mark to make sure you have done it correctly. Okay? This is a big giant mess. I want to make sure you can catch what you need out of there. This question should take you probably about a minute to do number 1. And remember, every name I write down here, the letters can be reversed. Yeah? As long as you have the same 2 letters I have, you've got it right. And that's a minute. Would anybody like to give me one of the radii they found? James.
OE.
OE. That is definitely a radius. You could have also said EO. EI, EIO. What is another radius? No, not you, James. Karina.
OJ.
OJ, or of course JO, a very powerful word in Scrabble. JO. Two-letter J word. Very useful. And finally, OF. All right. Everybody good? Great. What are the two tangents? What are the two tangents? Somebody volunteer. AB? No, because AB touches the circle twice, Omar, so it cannot be AB. Not you, James. I know that you know. You are good at this. I also know that Karina knows, because she is good at everything. I would like other people to have a chance to answer in this class. Because based on the last couple of tests, apparently I've been doing a very poor job of teaching you math. So somebody in the class that is not James and Karina needs to tell me two tangents. I don't know what a tangent is, Mr. Myers. Yes, you do, because we just defined it on the next piece of paper in your notes. You wrote it down. A tangent is a line that touches the edge of a circle once. Sean. Pardon me? CED. So CD, you can go endpoint to endpoint, or of course DC. Maddie. HG, or of course GH. Well done. 2 points of tangency. A specific point where tangency has occurred. Now, if a tangent touches a circle once, then the point of tangency must be the point that it hits. What are those 2 points? F? E. Omar, no line hits A. F and E. And finally, 4 right angles. Remember, order doesn't matter as long as you have the right letter in the middle. Give me one of them. Pardon? OAB? AB is not, a right angle means it's a 90-degree angle. AB makes no angles. OE what? OED. That's one of them. OED. And of course DEO. What's another one? OFG. And of course GFO. Give me another one. OFH, and of course HFO, and give me another one. OEC, and of course CEO. Very well done, ladies and gentlemen. Now, what is the measure of each angle? This should take you, again, about a minute. Some of you are already done. I am testing you here, of course, on your ability to read these diagrams. So, what's this guy? You just follow the letters. O, B, P. What angle did I just make? Which is 90 degrees. I want the measurement. P, Q, O. What did I just make? 90. And P, R, O. 90 again. I am testing on your ability to read these. When you read an angle, you go, just follow the letters. Find each value of x. Now this will take a little bit longer. What do you know this is? 90. So what do you know x is? 180
180 subtract 90.
minus 90, which is automatically 90, isn't it? So really I only need to do 90 minus 35, which is what?
Equals 55.
55. Good job. Over here, 90. So I know this has to be 90 minus what?
45.
25 to get
35 equals 65.
65 degrees. Everybody good? Lovely. Now, the end of you guys, because everybody stinks at Pythagoras. Do that page, and then of course, get out your textbooks that most of you probably did not bring, and work on page 388. Okay? Okay. I'm going to